Today I will introduce this project, Q-Learning Game Project. It is a Ghana game. As we can see, this is the structure of this project. Let me introduce quickly. First, this is the data directory. This contains the game logs, and this gameplay log maintain the information about every AI, every game that AI play, and the score, the total score that you recorded. And then this chain log .txt is the information that this project chaining, the record about chaining. As we can see, this is the total reward, the epsilon, alpha, and this. Alright. Okay, next is the chain result. It is the visualization about the epsilon with data, with alpha, with in 1000 games. And next is the hits and coefficients. Alright, this is the reward and epsilon. Okay, this is the Q-value JSON file. It contains the information about this action, AI action, and the Q-value of this. And this is the information about the status of this game. Next is the SRC directory. First is the AI Ghana. Okay, next is the agent. This Python file define the Q-learning agent, like some args. Okay, as we can see, some args and some functions. And next is the initialize Q-values file. It can initialize the Q-value in this Q-value JSON file, and initialize all action into 0. Okay. Next is the chain agent. This file defined the main process of chaining. Okay. Next is the access directory. This is the image about the background of wallet, and some enemy image, the gunner image. Okay. Okay. By running the game, this image, the enemy and gunner, will randomly show in this game. Next is the sounds, like the attack sound. Okay. The game over sounds and the score sound. Right. Next is the Ghana game directory. This Python file just defined a game logic that by myself or anyone who run this Python. And as we can see, by typing on the keyboard, we can let the player move left, move right, and shoot. Okay, this is the main Python file of this whole project, because in this file, many functions are defined, such as the init, okay, the environment of this all game, and this result get state. Get state just get the x, y position of this player, and like this check bullet enemy collisions, or just this get reward. Yeah, this is the main, okay, the main function to get the total reward, and then it is recorded. All right. Next is the render Python. It just defined all the game show in the screen, and the sound played during the game. All right. Next is the loss config. It just defined the function, and it is to record the game log and chaining log during chaining, or just during the AI playing this game. Alright, this is the run game Python file. Yeah, by running this file, we can see how AI play during the game, and this is the chain file. By running this file with args, this ITER, we can define how many rounds that the chaining will consist in the played. Alright, next I will show you how we play this game by ourselves to see how the game played, how the enemies be created, how the player move and shoot. Alright, let's run this Python file. Okay, as we can see, this is the main process of this game. Like, we move right, the sound is played. Alright, can you hear that? We shoot, we move, and on the left side. Alright. Okay. We can see the score is changing, right? Okay, let's see how what will happen if we yes, create when the player collide the enemies. Right, next I will show you how this project chain. Okay, let's open this terminal and clear and run this Python chain. Okay, and remember to take this args like ITR for only 10 rounds. Okay, 10 rounds. Yeah, and we can see in this console like the epsilon is decreasing slowly, as well as this alpha, right? And we can see in this chain log.txt, we can see this information like the time and the chaining record of the whole chaining process, right? And this is the total reward. How the AI play this game, right? Let's type a Python game. Yeah, this is just the whole process of this, how AI play this game. Okay, I do not play any action on the keyboard. It just automatically this AI play this game. And I define the rule that the AI will detect the nearest enemies on the screen and decide whether to shoot. Right, as we can see just now, the AI avoid the enemy by avoiding collide. Alright, this game is over, let's continue, okay? And this rule is, in this game is, the status maintain 3 variables. First is the speed that the enemy fall down, and the second is the X position. And this X position is the difference between this AI and the nearest enemies. Okay, let's continue. The third variable is the Y position, the difference of Y position between the AI and enemy. And by one by one chaining round, one by one chaining round, the stage action reward will be recorded and maintained, and then according to the Q-learning formula, the Q value will be updated. Alright, first we will get the old Q value, and then we will compute the max value of next state. Right, let's continue this game. We compute the max Q value of next state, and then according to the Q-learning formula, we updated this Q in the QJSON file. After all this, we will write back all this information into the Q value JSON so that the AI will consistently do the best action by the Q value, like when to move right, when to move left, when to shoot. Okay, give more details about the Q-learning formula that used in this project. Let's just see the process of chaining. Okay, this is the chain function, right? This is the environment created, the agent created, right? This is the data of the visualization. Yeah, right. This is the main iteration in this chaining. Okay, first, let's just see this. Okay, in this iteration, we get the action of according to the state, right? Let's see the choose action function. It is according to the epsilon greedy. Okay, the epsilon greedy. When the epsilon is high, we random choose the actions. Okay, like this, randomly choose an action. And when the epsilon is decreasing, we will choose the max Q value action in the Q table. Okay, and next is we get the next state reward and done by this function. Okay, by this function, it returns the state reward and done. And then the agent will store this information into this array. Okay, and then next we do this improvement, and if the steps count is higher, then max steps will let done become true and exit this iteration. And then when this one is over, we will update the scores by these two args, these two parameters. Let's see this function. Okay, this update scores will first get the whole history of the whole round the AI moves, and then in this iteration, we click into this function. First, we will get the old queued value in the queue table, okay, in the queue table, and then according to the Q-learning formula to compute the new queue value, okay. Let's see, this is according to the formula, and then we update the queue table, right? But there is one point we should notice is that when the training round is over, we update the queue value, not in every step, because we will get the whole history moves like this. We will first get the whole history moves, and then we call this update queue function to update the queue value, right? It's the hardest part in this project, and one problem that confused me for a few days. Yes, a few days. Okay, the first and the biggest problem is that in this getState function, the status that used in the queue value table as its key is the main problem that confused me, because in the beginning of this the program, in the beginning of this program, I use different state like the bullet, the number of bullets, the position of AI, and I even use the nearest 3 enemies, and each of these enemies' position, all of them that I use for the key contained in this status, alright? And after I train and consistently change the rule of this game, I focus that the result of this is not good, because the state is too complicated, and the AI will not learn that good that well under this definition of state. So in the end, I use just this 3 variable, okay? Because after one and one chaining, the AI just need to focus on the nearest enemy and then move to its direction and then shoot it, get reward, and then update the queue value. Just that easy, right? Just that easy. And in the beginning, the states are too complicated. The AI, after training, and according to the queue value table, the AI just don't know where to move, and when the enemy become more and more in the screen, the AI just don't know how to move and how to shoot, and it just shoot the bullet, right? This is the main and the biggest problem for me. Here I correctly defined maybe the best suited for this program, for this project, the enemy speed, the X position difference, the Y position difference in the state, and more importantly, I correctly defined the logic of the queue value update in this function, right? In this function, get the old queue value and then compute the new queue value, and according to the Q-learning formula to compute the new queue value, and then updated the queue value table, as well as this use the epsilon greedy to choose action by like avoid the enemy, like choose when to move left, when to move right, and shoot after moving, as well as this let the AI moves change it into a history array, and then do an iteration by getting the state and action for every round to update the queue value. So after these 2 steps, the queue value table just consists of, for example, in this position, the AI will choose the best queue value to shoot, right, after training. And according to this recording in the training, the AI will learn better and better, and then generally choose the best action.